Hey guys, it's Coach Coke. I'm going to go over Intro to Circles here with you today. So let's start off with what a circle is. Now all points on a circle are equidistant from the center. Alright, so if I put a dot here in the middle of this circle and I name that point A, alright, this would be circle A. Okay, we name the circle with that point in the middle. Okay, so my center here to this circle is point A. Alright, now if I pick another point somewhere along the circle and I connect the center point to that other point, we're going to name that point B out there, and I connect those two, that would be a radius. Okay, so a radius goes from the center to the side or to one point somewhere on the circle. Okay, so when I name this radius, this is a line segment, so we would name it AB with a bar over the top. Alright, the next special segment that we have in circles is called a chord. Okay, a chord is when is a line segment whose endpoints lie on the circle. So if I connect these 2 points that I've just created, let's call this C and D. If I connect these 2 points, that is a chord. Okay, so that chord, once again, we name it just like we did a radius. It's a line segment, so we name it CD with that bar over the top. Alright, the next special segment is called a secant. A secant is a line that intersects a circle in exactly 2 points. Okay, so if I put 2 more points on this circle, okay, let's name these E and F. And I draw a line through these, not a line segment, but a line. So I put my arrows on the end here to show that this is a line. Okay, this is called a secant. So once again, a secant is a line that intersects a circle in exactly 2 points. When we name this, we would name this EF with that bar over the top, but this time I'm going to put arrows on the end since it's a line instead of a line segment. Alright, the next thing we're going to talk about is a tangent. Okay, a tangent is a line or line segment that intersects a circle at exactly 1 point. Okay, so now let's say I put a point here on the edge of this circle and I draw a line through that point that only touches that circle at that one specific point. Okay, it looks something like that. Okay, let's say that point, let's just call it point A for right now. Okay, that's point A. Alright, if I put some other point out here, let's call that point B. Alright, that's a tangent. Okay, so that's a tangent line. So when I name that, I would name that A, B with a line, with a bar over the top. Gotta put my arrows on here. Alright, so that's a line, that's tangent line AB. Alright, the point of tangency is that point where the tangent line intersects the circle. So my tangent point here would be point A. Alright, the next thing we're going to talk about is the diameter of a circle. Alright, a diameter is a segment that has endpoints on the circle and passes through the center of the circle. Okay, so let's go back and put that center point on the circle right here. Alright, now let's put some points on the sides there, and let's draw that straight line that goes through all 3 of those points right there. Okay, now that would be the diameter of the circle there. Alright, let's say we called this point A, this point B, this point C. Okay, when we name that diameter there, we'd name it using the 2 endpoints. So the 2 endpoints here are A and C. Put that bar over the top, so that's a diameter. Alright, the circumference is the length or the distance around the circle. You guys have probably seen this formula before. Circumference equals 2 times pi times r. R is the radius. Alright, an arc. An arc is a portion of a circle between 2 endpoints. Okay, so let's say I have 2 endpoints here on the circle. Let's just call it C and D for now. Alright, so the arc would be that whole segment between those 2 points right there. Okay, so when we name an arc, it's kind of similar to a line segment that we use the 2 endpoints there. So C and D are my 2 endpoints, but instead of a bar over the top, I'm going to put a little arc over the top. Okay, so that's how we name an arc. Now, arcs can be minor arcs or major arcs. Okay, an arc of a circle whose measure is less than 180 degrees, all right, is a minor arc. So for instance, LY right here, these points between L and Y right there, that would be a minor arc because that is going to be less than 180 degrees. Okay, remember a straight line is 180 degrees. Okay, you can see P and L right there. That creates a straight line. That arc is not all the way to P. All right, so we would name that minor arc right there LY, and we put that little arc above the top of it. All right, now a major arc is an arc of a circle whose measure is greater than 180 degrees. All right, when you name a major arc, you have to use 3 points so that you can show direction here. Okay, so let's say that I wanted to go from L and I come all the way around. That's 180 to P right there. If I keep going, that's greater than that, right? All the way to Y right there. I know I kind of covered up the letters right there. All right, but my my arc there could be L. What did I go through? L, B to U there. So L, B, U. Okay, I use 3 letters when I'm naming a major arc. All right, a semicircle is an arc whose measure is exactly 180 degrees. So we talked about diameter a second ago. So the diameter, like for instance, would be LB in this problem. So I put LB. All right, so if it's a semicircle, it's just exactly 180 degrees. So LB, I'd put that little minor arc symbol right there for that one. Okay. All right, let's go to page 2 here. All right, so let's talk about central angles next. Okay, a central angle is an angle whose vertex is the center of the circle. Okay, so I have my circle here. Let me put my points on this real quick. Let's put point B here in the middle. Let's put A and C on the outsides here. All right, let's connect these dots here. Let me name them first. Let's call this A. Let's call this one B. Let's call this one C. All right, so I've got basically 2 radiuses here, or radii, I should say. Okay, when I connect those dots right there. All right, now let's say that this is a 60-degree angle right here. Okay, so this angle right here is 60 degrees. All right, so a central angle is an angle whose vertex is the center of the circle. Okay, so you'll see there I have a central angle that's 60 degrees. All right, let's talk about an inscribed angle next. Okay, an inscribed angle, let's say I put my points on my circle like this. Okay, let's go D, E, and F. All right, let's put that angle E here in the center. So when I connect my dots like that, that would be an inscribed angle. So when I name this angle right here, I would name this angle DEF. So an inscribed angle is an angle whose vertex is on the edge of the circle, not in the center of the circle, but the edge. All right, congruent circles are next. All right, two circles that have the same congruent radii would be congruent circles. Okay, so let me do this. There's my center of my 2 circles. There's another point on each of those. If I connect those dots right there. Oop. Okay, let's say that each of those measure, let's say 3. That's 3, and that's 3. Those will be congruent circles because their radiuses are congruent. All right, concentric circles are next. Okay, concentric circles are 2 or more circles that have the same central point. So you'll see here this point right here in the middle. No matter if you're talking about the smaller circle or the bigger circle, those are concentric circles because they have the same center point. All right, now let's do a couple of example problems down here at the bottom. Oop, not sure how I got that point down there. Erase that. All right, so first off here it says name one of each of the following parts of the circle. So the first thing we're going to name is the center of the circle. Okay, so we talked about this center point J right there in the middle, so my center here would be point J. All right, the radius of this circle, there's a couple ones that you could use here. Let's just go J to A. Okay, that's from the center to another point along the circle. So JA with a bar over the top. All right, the next thing would be the diameter. There's 2 here that you could use. You could either use LE or FA. I'm just going to pick LE for right now. Okay, because once again, the radius goes from, the diameter goes from one side of the circle to the other and goes through that center point. All right, a chord. Look at CD over there on the far right. That would be a chord. That's not the diameter. So CD. Okay, the next would be a secant. So we talked about a secant being a line that goes through the circle. So it's kind of like a chord, but it keeps on extending. There's those arrows on the end. You see HG over here on the far left. That would be a secant. Okay, this time I'll use the bar, but I got to put arrows on the end for a secant. Okay, tangent, same thing. A tangent's a line over here, but it only intersects the circle at one point. So you see BK up there at the top. BK would be a tangent. Alright, the point of tangency would be the one point where it actually hits the circle, so that would be point B. Alright, a minor arc. You could pick several in this picture. Let's just look up there at the very top. You see between L and A, that's clearly less than 80 degrees, or I'm sorry, 180 degrees. So LA is a minor arc right there. Okay, it looks like that. A major arc, let's start at point L again, okay, and we'll have to go, if we're going to the left after we start at point L, we'll have to go past E because E would be exactly 180 degrees, so we could go LE, but we'd have to keep going one more point. Let's go to D. So LED right there would be a major arc. Alright, then we got two questions down here at the bottom that want to actually find the measure of these two things. So the measure of FE out here, you see right here where this 30-degree angle is right here. Well, FE is out here along this arc. Okay, the central angle and the arc angle are the exact same. So if this is 30 degrees, then FE is also 30 degrees. Alright, if that is true, then if we go the major arc FEL, alright, F to E to L, if we wanted to figure that out, we know that F to A, let me do this in red here. If I'm going from F to A, that's 180 degrees, right? Well, if I keep going all the way to L right here, this would be another 30 degrees. Okay, these two angles, this angle here and this angle here are vertical angles, so this would also be 30. Okay, so that means this is 30 out here. Okay, we said that it was 180 degrees. This part right here was 180. So if I added 180 plus that 30, so 180 plus 30, I would get that that whole major arc right there is 210 degrees. Alright, that's it for Intro to Circles.